We present RetroDepth, a new vision-based system that accurately senses the 3D silhouettes of hands, styluses, and other objects as they interact on and above physical surfaces. We use a simple, easily reproducible setup comprising of 2 infrared cameras, diffuse infrared LEDs, and an off-the-shelf retro-reflective material. The retro-reflective material aids object segmentation by enhancing the contrast of any object positioned between its surface and the cameras. RetroDepth enables touch and mid-air interaction. Here we demonstrate manipulation of virtual objects using a combination of on-surface and mid-air gestures, including selection, rotation, translation, and scaling. RetroDepth also allows for interaction with custom physical widgets, like this color selection dial. Moreover, physical tools not covered in reflective material, such as pens, are also tracked with high precision. By letting users seamlessly switch between pen, touch, and 3D input, as well as interaction with physical widgets, RetroDepth offers extremely rich interactions in a variety of styles in a single package. In this part of the video we demonstrate some of RetroDepth's tracking features in more detail. First, we see the 3D contour of a user's hand visualized above the tracked reflective surface. The position of fingertips is available, including their orientation. The pointing direction and precise tip position is also available for stylus-like tools. When tracking hands and fingers, RetroDepth offers touch detection with very high precision, as well as accurate depth estimation of fingers and objects above the surface. We are also able to reconstruct a dense depth map of tracked objects using their 3D contours. Here we see rectified stereo images from the infrared cameras. Objects placed on the reflector can be segmented by masking out the convex hull of the retroreflective sheet. Once the objects are segmented from the background, our novel stereo matching algorithm efficiently recovers the depth of the contour of the object. Depth within the shape can also be interpolated from the 3D contour, as shown here. For more details, please see the paper. Demonstrating the precision of RetroDepth's contour-based depth estimation, we show how a malleable, reflective surface can be used to extract hover, touch, as well as pressure information, while also providing haptic feedback to the user. We can also use RetroDepth to robustly track and detect objects to enable accurate pen input in an example drawing application. Beyond pens, we can extend tracking to arbitrary shaped physical objects in 3D space, allowing us to directly manipulate virtual objects mapped to physical tokens. We conducted a comparative study evaluating 3D pointing task performance with state-of-the-art commercially available systems. We also compared their touch accuracy in a separate second study. Our study shows improved accuracy of RetroDepth over these other sensing systems. For details, please see the paper. Our stereo matching algorithm is extremely efficient, allowing computation on mobile phone devices. In this example, we show a simple 3D pen drawing application that works on a standard stereo camera phone. One of the main advantages of our system is that it enables easy integration into existing multi-touch enabled user interfaces. This gives the user flexibility to choose to interact on the surface, in midair, or seamlessly switch between the 2 modalities. In this demonstration, we showed the precision of RetroDepth, allowing the user to touch type on top of the surface. We have presented RetroDepth, a lightweight camera-based system that allows for seamless switching between a variety of natural user interaction modalities. It enables high precision and expressive input on and above physical surfaces with hands, styluses, and other tangible objects.